All right, good afternoon, everybody. Welcome to Algebra 1 class. As you can see, our objective for today, we have two content objectives. We're going to be creating equations in two or more variables to represent relationships between quantities. We're also going to be graphing these equations on coordinate axes with labels and scales. So our language objective is really to decode the word problem while trying to construct a linear function. And we're going to continue to use yesterday's key concept, which was slope. And today we're going to really build on that to strengthen our understanding of intercepts and how they can be useful with graphing. So, you've already been given your opening activity, which looks a little bit like this. It says investigation, standard slope-intercept form. So if you wouldn't mind, someone please read the scenario in the big box. Any volunteers? Peter, thank you. Please read the story.
When Jamal went away to summer camp, his family put $300 in the bank to pay for his meals for the next 3 weeks. If Jamal spends an average of $12 each day on food and drinks, how much money is remaining in the bank?
Okay, so folks, I'd like to use that information to answer the questions on the first side of the page. And we will regroup and go over them once you've gone through it. We're going to go about 2 minutes.
Question for the 2 week, should
Sure.
we include a weekend too?
Yes. And folks, we're using our strategy of guess, check, generalize to construct equations once again. I just want to remind you of that. We've been using that since the beginning of the year. All right, folks, about 30 more seconds. All right, folks, so let's start the beginning of our story. Jamal shows up at summer camp. So after 0 days of buying meals, how much money is in his bank account?
300.
300. All right, so we're starting at $300. After 1 day of purchasing meals, how much money is remaining in the bank?
288.
280. Can you tell me where you got that, Mom?
I just subtracted 12.
All right, so first day, we were saying that he has an average of $12 per day. So after 1 day, he spent $12. So Jessica, what would you think about 2 days? How much is remaining in the bank?
276.
276?
Yeah.
Very nice. Excellent catch. And where did you get that number?
12 times 2, then you get 24, 300 minus 24.
All right, so before we said 1 times 12, and we subtracted that from 300. And now we said 2 times 12, and we subtracted that from 300. All right, how about 3 days? How much is remaining in the bank after 3 days? Peter, what do you think?
264.
264. Excellent. And can you explain to me where you got that amount?
300 minus 12 times 3, which is 36.
All right, so 3 times 12, and we subtract that amount from 300. All right, so why don't we just shout out some answers? Let's fill in this table real quickly. How about 4 days? How much is in the bank?
254.
252.
252, I think. All right, after 1 week, how much is remaining?
200.
Let's go through our, again, how do we do it over there? We take the number of days, multiply by 12, which gives us 84. And take that from 300, 1 week, how much?
16.
216. How about 2 weeks? Anybody think of a way we might be able to jump forward on the table without having to evaluate the function again?
Double the 84.
There we go. So 7 days is equal to 84. 14 days is going to be 168. And once again, we subtract that from 300. So you see these repeated calculations should be helpful in constructing a linear function. I'm going to get that into a second. So, I want to write on your little thing here, but this should be
132.
132. If we go further,
48.
21 days would be 84 times 3. 21 days would be 252. Very nice. We subtract that from 300 and we've got $48 remaining. Now, how can we use this repeated calculation? What do? We guess, check, we generalize. So we've guessed, we've checked, we've guessed, we've checked. We've completed our table. What do you notice in common with all the different calculations? What's happening over and over again?
12.
We're multiplying a number by 12.
You're subtracting 12 each time, too.
We are subtracting 12, absolutely. So we're subtracting, we're taking away 12 from our total. And what else do we do? We're subtracting this number from what?
300.
300. So we multiply by 12 and subtract that quantity by 300 over and over and over again. So I want everyone to take 30 seconds and talk to a neighbor and think about how we can use this information from all the guessing and checking that we've done to write a linear function. All right, about 30 seconds.
300 is 1 intercept and negative 12 is the slope.
All right, so anybody want to volunteer an idea? What do you think might be a good function for this? Jessica, do you want to answer up on the board? I think I heard you mumbling an idea.
Y equal to negative 12x plus 300.
300 is my y-intercept and the slope of negative 12 per day. As we could plug in, day could be my x.
Excellent. Anybody have another guess that was kind of similar to this one?
Is it okay to write 300 minus 12x?
Yeah, you know, I will say that sometimes we can see the meaning behind the function if we rearrange it. I know we've been sort of brainwashed to think of slope-intercept form as y equals mx plus b. And one way of thinking about b, what's a definition of intercepts? Think about what we've talked about, okay? My classroom, we have a poster right here talking about intercepts. They're so very important. It's specifically the y-intercept. In this case was 300. What was the significance to the story of 300?
Starting.
It's the starting point, isn't it? I think it's really helpful to think about intercepts as a place we start. So why not start our function with a b? So I think our tendency, again, is to think of slope-intercept as y equals mx plus b, but there's absolutely no reason why we can't also think of it as starting at b and then adding our mx, which is how things are changing. In this case, we could rewrite the function as I start with 300 and I take away $12 for every day I'm at summer camp. Can someone tell me what's wrong with this linear function? Because a student made an error and I've made the same error, and we can learn a lot from our mistakes. So what is wrong about this particular function? Marissa, do you see the error?
No.
All right, well, let's go back to the question. Everybody reread the question. 10 seconds, let's talk about what's going on with this function. It's a small error, but I think it's an important one because we are trying to build meaning with our linear function. Anyone see it? 5 seconds. So what does x represent?
Day.
X is representing days. And what's our y represent?
The amount of money left in the
Amount of
bank.
money in the bank. So when we were given this equation, we were given specific variables.
D.
And in this case, we did not use
D
them
and
because
B.
once again, we're going on autopilot. Okay, it's always y equals mx. Well, we were asked very specifically to use D and use B. And this is really important, you know, we don't always want to focus on standardized tests, but MCAS, one of the biggest mistakes we can make in standardized testing, MCAS, SATs, is not answering the question the way it is asked. And, you know, we've demonstrated a lot of understanding and meaning in this function. Now, the only thing that we're missing is, you know, proper notation. So, I would say, how can we rewrite this function? Any volunteers, Jessica?
B is equal to negative 12 D plus 300.
Very good. So the amount of money in the bank is equal to my $300 minus 12 for every day I'm at summer camp. Excellent job. Excellent job. All right, now, I would like you to take about 2 minutes. We've already found some points from our table. You've been provided with a graph on the back side. So please spend a couple minutes locating these points on your graph, plot them, and, you know, we have talked a little bit about this. What kind of function is this?
Linear.
It's a linear function. And what kind of graph do linear functions have?
A line.
Well, they're all kind of lines, aren't they? If we connect a bunch of dots, we are going to get a line. But very specifically,
Straight line.
it's a straight line. So please use some sort of straight edge and connect the dots once you've plotted a few points. Do we have to plot every point to draw a linear
No.
function? Let me ask that again. Do we need to plot every point? No, just make sure you got a few there. It's going to give you the opportunity to draw a graph. And again, let's go 2 minutes. Alright folks, somehow my graph has disappeared, so let me come around and check your work. Okay, so we want to go all the way to the beginning of our story. One thing about graphs, we don't need all the points to draw an accurate line. However, we want to make sure our line accurately represents all the data we have. So please make sure you extend the line completely. Alright, so there are a couple of questions in analyzing our own graph and thinking about how this graph represents the story that we're talking about. So, as the number of days increases, what happens to the amount of money in the bank?
We decrease.
It does decrease. And what do you notice about the slope of the line of your graph?
Decrease by 12.
Okay, so the slope, which we use m, is negative 12. We have a decreasing quantity, and we have a negative slope. Anybody think that's a coincidence? So what we find is that a story that decreases is going to have a negative slope. So we literally see that bank account draining every day, and that line goes down, down, down. Bless you.
Thank you.
All right, so what does the slope represent in this story? We talk about how it's going down, it's going by 12. The slope is 12. What does that represent? Peter?
The amount of money you're spending a day.
Yep, absolutely. Now, what about the intercept? Okay, we talk about this. What's our y-intercept in this particular story?
300.
It is 300. So what does that represent in the story? So we have the value, and I think in math class we spend a lot of energy trying to, attach values to our answers. But we want to make sure we are including the meaning. So what does that 300 mean? What does the intercept actually mean to this function?
0 days the student have not spent any money.
All right, so that's a really good point. It's where d is equal to 0. What else? And we see that connection when we talk about an intercept. One of the coordinates is 0. In this case, it is d. What else? What's happening in the story? When the bank has $300, right?
We haven't spent any money yet.
Haven't spent. So beginning of summer camp, right? And I think that's really how we have to think of intercepts. It's the beginning. Is it an easy point to graph? Did anybody use 0, 300? Yeah. And I think that's also another reason why intercepts are so important. Not only is it the beginning of our story, but it's also very easy to graph. It's very easy to evaluate 0. If we take our function 300 minus 12d and plug in 0, there it is. There's your answer. So keep that in mind when we get to graphing other types of functions. On that note, let's transition to activity number 2. So let's go through the beginning of this together. We have another story. Bryce, would you be so kind as to read to us what's in the box at the top of the page?
The freshman physics classes are selling Falcons hats and sweatshirts to raise money for a field trip to Canby Lake Park. They earn a profit of $5 per hat and $10 per sweatshirt.
All right, so our physics teachers used to take the kids every year, but they're having some fundraising issues. So let's see if we can help them out. Now, in this story, we kind of say there's 3 variables. So can anybody say, what's one thing that's changing in this story? And let's just use words. Again, we're really just trying to get to the meaning of the story. So what is one thing that's changing in this story?
The number of hats?
All right, so number of hats is definitely something that could be changing. It's something we don't know. We don't know how many hats they're going to sell.
Number of sweatshirts.
Number of sweatshirts. Very good. Number of sweatshirts. All right, lastly, there's one other thing that isn't really given to us in this scenario, but it is something that is changing. Anybody see it?
The total?
Yeah, we don't know what their goal is. We don't know how much money they've raised. So how about total money raised? So right now, I want you to think about real quickly, find the profit made by these 3 students. Please show your work. So again, we're going back to this concept of guess, check, generalize. So here's a couple of guesses. 30 sweatshirts and 50 hats. 12 sweatshirts and 20 hats. Figure out how much money you would make if you were in the physics class selling hats and sweatshirts. Why don't we go 30 seconds and then we'll take a look at our calculations. All right, Jessica, can you help us out with Alonzo? How much money did Alonzo make?
850.
$850.
Wait. 550.
$550. Oh boy, he just lost a lot of money. Nice try, Alonzo.
It was like 30 times 10, that's 300, then plus 50 times 5.
All right, so you've got 30 times 10 plus 50 times 5. All right, so that's Alonzo. Anybody got Victoria? Here you have Victoria's money?
I have 220.
$220, and where did you get that?
I did 12 sweatshirts times $10,
Okay,
and 10 hats times $5. Or I'm sorry, 20 hats times 5.
20 hats times $5. All right. Marissa, you got your balance calculations?
200.
All right, $200. Alonzo's in our winner, but what did Trayvon do to make that $200?
He sold 15 sweatshirts for $10 each and 10 hats for $5 each.
Okay, so you told me 15 times 10 and 10 times 5. Where'd the 200 come from?
I added them.
Thank you. All right, so we added them together. So folks, I want you to look at all the calculations that you've told me on the board. What do you see in common? So if we get back to this method of guessing and checking and generalizing. So in general means, what do they have in common? Generally, what are we doing over and over again in these calculations? What do you guys see? Any observations? What's one observation you see in these calculations that they seem to share in common? Peter?
Times 10.
All right, so there's multiplying by 10. That happens over and over again.
Then times 5 with the hat.
All right, so times 5 over and over again. One other thing. It's going to help us construct our equation.
Plus.
Yeah, we're adding our products, aren't we? So we're adding our products every time. So, excuse me. Let's write an equation that shows the relationship between these three variables. So the blank depends upon the number of what? So let's think about, this is a scaffolded question. We got a couple blanks here. Let's guess what the teacher's thinking. The what depends upon the number of what? Think about your story. What do you think this first blank is? What is our dependent variable here? What is depending upon?
The total.
Okay, total what?
Money, right?
Cost.
Total sweatshirts?
Yeah.
Total money. The total money depends upon what?
Number of hats sell and number of sweatshirts sell.
Yeah, so again, I don't want to hit this. So the number of hats
Hats
and
number.
sweatshirts sold. And we see that over and over again. Our quantity comes from the number of hats, number of sweatshirts times 10 plus the number of hats times 5. So what might our equation look like if we use this repeated calculation to do our checks? Anyone want to give it a shot in writing our linear function? Anybody, any brave soul want to try to construct a linear function based upon our repeated calculations? Peter, what are you thinking?
Y equals 10s plus 5h.
Very nice. So our total money is going to depend upon the number of hats, which is $5 per hat, the number of sweatshirts, $10 per sweatshirt. We add together and the sum is our total amount of money. Great. Is there any questions about that? All right, folks, excellent job. Now, if we were to make $600, I believe that is their goal.
600 equal to 5h plus 10s.
All right, so we would rewrite our equation. Now we have one of the unknown quantities. And realistically, I said three variables. There was two variables and one unknown. There was one thing we didn't know, which was our target. Now we have a target. Now what I'd like you to do is find three different quantities, combinations of hats and sweatshirts sold, that allow their students to reach this goal of $600. And then once you have those, I'd like you to turn the page over and find those points on your graph. Okay, folks, we're going to take about 3 minutes to do that. And I think we're done. Thank you, folks.
This is great.
Mr. Cambridge Falcons.
Steal this worksheet.
Please do.
I got it.
Oh,
As they say, imitation is the highest form of flattery, and teaching is still.
Teaching.